Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syazwan bin Muhammad Nazari. Matric number AA191774. So our group will present about the production of malic acid. For introduction, malic acid is a very important chemical for the industrial chemistry. Malic acid is an important raw material used in manufacture of lubricant, additive, unsaturated polysterenes, surface coatings, plasticizers, copolymers, and agricultural chemical. It is an organic compound that is a dicarboxylic acid, a molecule with a carboxyl group. Malic acid is the cis isomer of butane dioic acid, whereas fumaric acid is the trans isomer. So for the first objective is to extend the knowledge about the production of malic acid from industry. Second, to find the effective technique on producing the malic acid in order to improve the sustainability industry and environment. And the last objective is to improve and design the operation of process system to minimize the waste and pollution. So that's all from me. Thank you.
Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Lia Zafira binti Naim, matrix number AA191377. Today I'm gonna talk about the process flow of maleic acid production from the oxidation of N-butane. This process consists of three parts: reaction, MAN recovery, and purification. We go to the first part, reaction. At first stage, air will be compressed using a compressor, and then it is mixed with superheat evaporated butane. The gases enter the multitubular reactor containing the catalyst, which consists of vanadium phosphorus oxide supported on silica. The reaction gases are cooled with a mixture of nitrate and nitrate salt. The molten salt is then passed through an external cooler and cooled by boiler feed water, producing steam. The reactor exits gas stream, which contain of maleic anhydride in bracket MAN, water vapor, carbon dioxide, oxygen, nitrogen, and unconverted butane. This stream is partially condensed, and the condensate stream is sent to the purification area, while gas stream is sent to an absorber column for recovery of the remaining MAN. Second part, MAN recovery. MAN that was not condensed is recovered by absorption with a solvent. Nitrogen, carbon dioxide, carbon dioxide, and unreacted butane is removed at the top of the column. This stream is sent to a thermal oxidizer for incineration at off-site facilities. The recovered stream from the bottom of the absorber column is sent to a solvent recovery column, in which MAN is recovered as the distillate. The MAN recovered in this step is mixed with the condensate from the reaction area and then sent to two purification steps for obtain pure MAN. The solvent recovered from the bottom of the solvent recovery column is returned to the absorption column. A small portion of the solvent stream is sent to a solvent purification step for removal impurities. Last part, purification. The purification area consists of two distillation columns for the removal of light and impurities and heavy and impurities. The final products from purification is MAN with purity greater than 99.8%, and the products will rapidly hydrolyze to form maleic acid in the presence of water. And that's the end for my part. Thank you.
Assalamualaikum. My name is Muhammad Daniel. My matrix number AA191040. Okay, today I will continue to present advantage of conventional process. We using butane and butane instead of benzene lead to lower the cost of the raw material and obtain the better quality of maleic anhydride because of the efficient of the separation and purification step, utilizing organic solvent as a media. and then we can lower the environmental impact because of benzene is known as carcinogenic substance. Also, we use the fluid bed reactor over the fixed bed reactor is to feeding of the higher hydrocarbon concentration within the expression limit, and also the excellent heat transfer, and then it can increase steam production suitable for conversion to power without fuel. And lastly is to reduce power consumption. Okay, next the disadvantage. Butane is highly flammable, so there is a risk of burn or explosion. Butane also can be death from choking, suffocating, asphyxiation, and form of heart failure known as SSDS or sudden sniffling death syndrome cause of butane gas. And inhalation of it can cause a narcosis, cardiac arrhythmia, drowsiness, and aphasia. Burning it produces nitrogen dioxide, a highly toxic gas. It causes asphyxiation when released in confined area. Okay, that's all for me.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Al-Faikam Al-Shari. In 911 I'm about to present the side effect of malic acid and the precaution. Malic acid and hydride rapidly hydrolyze to form malic acid in the presence of water, and hence environmental exposure to malic acid are unlikely. Acute short-term health effect may occur immediately or shortly to malic acid. The workers especially can severely irritate, burn the skin and eyes with possibly eye damage. Inhalation exposure of human to malic acid has been observed cause irritation of the respiratory tract, which causing coughing, vomiting and shortness of breath. The higher level of exposure may cause seizure and coma. The long-term health effect can occur at some time after exposure to malic acid and can last for months and years. The exposure of malic acid has been observed to cause chronic bronchitis, asthma-like attack and upper respiratory tract and eye irritation in workers. Other long-term effects of malic acid and can irritate the lung. Repeated exposure may cause bronchitis to develop with cough and shortness of breath. Malic acid may also affect the kidneys. So the precaution step, way to reduce exposure, enclose operation and use local exhaust ventilation at the site of chemical release. If local exhaust ventilation or enclosed operation is not used, respirators should be worn. Wear protective work clothing. Wash thoroughly immediately if exposed to malic acid and at the end of the work shift. Post hazard and warning information in the area. So for work practice, workers whose clothes is contaminated need to change it promptly. Do not take contaminated work clothes to home because it could expose to others. The contaminated clothes should be washed if exposed to malic acid. Eye washing mountain should be prepared for emergency use. Do not eat, smoke or drink in the place where malic acid is handled. Use vacuum to reduce dust during cleanup. Clothing, avoid skin contact malic acid resistant glove. Wear resistant glove and clothing. All protective clothes need to be cleaned every day before use for work. So for eye protection, wear impact eyes protection with side shield or Google. So that's all from me. Thank you.
Assalamualaikum. My name is Irdina Fatihah binti Zulhelmi, matrix number AA190550. So now I'm going to talk about the improvement that we can do to achieve sustainable chemistry. The first improvement that we can do is by remote asset management. Chemical process plants need to evolve and make full use of smarter technology. By using cloud technology, process equipment for such reactor can have constant monitoring and storage on data on remote servers anywhere far. Any malfunctioning in process equipment can be instantly identified by accounting the materials enter and leave with mass balance method. Administrator of chemical companies will be alerted swiftly when something odd happens to shut down the faulty system. The remote asset management has been proven to be more effective and generally safer rather than on-site physical presence near as it decreases the number of volatile environments. The threat of a larger scale disaster can also be reduced. The second improvement is downsize the integrate chemical production. A continuous operating hour with an abundant amount of supply chain can create a workload to the process equipment. It is good to have a mass production fulfilling the product demand. However, longer supply chain creates challenges for managing safety, responsiveness, and sustainability. The biggest downside of all is a sudden and severe change in the chain. It is safer and convenient to break the production chain into small bulks. This will make room for the plant equipment to rest from abundant workload. Moving on to the conclusion, there are two ways that we can do to produce maleic acid, which is by using benzene or by using butane. But most researchers and companies prefer to use butane because butane presents no environmental problem. In fact, N-butane is recommended as a substitute for plants built after April 18, 1980, which proves that butane is a lot more environmental friendly than benzene. So that's all from us. Thank you.